मोहतरम नाजरीन और अजीज़ तालिब इल्मों, अस्सलाम वालेकुम। डॉक्टर मोहम्मद अनवर राव आपकी खिदमत में हाजिर। आज का लेक्चर हमारा 10वां लेक्चर है, 10th लेक्चर, कोर्स कैलकुलस ऑफ वेरिएबल, मल्टीपल वेरिएबल है, जिसको आप कैल 2 भी कहते हैं। इससे पहले के लेक्चर में हमने पार्शियल डेरिवेटिव्स और चेन रूल किया था। कैलकुलस और एनालिटिक ज्योमेट्री, चाहे वो 2 डायमेंशन हो या 3 डायमेंशन हो, इसमें वेक्टर्स की भी बड़ी जरूरत पड़ती है। गो के वेक्टर्स इब्तदाई कंसेप्ट है जो कि आपको गालबन इंटरमीडिएट में इससे वाकफियत होगी, लेकिन फिर भी मैं ये चाहता हूँ कि इसका कुछ रिवीजन हो जाए। इसके बहुत सारे कंसेप्ट्स को हमने अपने आइंदा कोर्स में इस्तेमाल करना है, जैसा कि डायरेक्शनल डेरिवेटिव्स हैं और ग्रेडियंट ऑफ द फंक्शन है। तो इसलिए हम वेक्टर्स के मुतल्लिक आज पढ़ेंगे। What is vector? As you know, there are 2 types of quantities. One is called scalar quantities, which has only mass, and the other are vector quantities, which has direction as well as mass, just like velocities, force, acceleration, displacement. So these are vectors. The best way of representing a vector is a line segment, because a line segment has both the qualities. It has direction as well as the magnitude. So just like this is, you can say it is a line segment. So the length of this line segment is magnitude, and from this point to this point, which is pointing out, is the direction. Now this is a vector, this is another vector, this is another vector. So by giving different direction, it can change the directions, and by having different length, it will have the different magnitude. This idea is good in 2-dimensional geometry, as well it is valid and good in 3-dimensional geometry. So a line segment is the best tool to represent a vector. Let us see on the screen. So here is a line segment AB, which has arrowhead at the point B. B is called head and A is called tail. The direction of this line segment is the direction of vector. The distance between the point AB, the length of the segment AB, is the magnitude. The notation for vectors, we know, if we are given the tail and head, just like here, then AB headed by this arrow is one of the notation, or a small letters underline in type, it is a bold type. This is also a notation of the vector AB. What is the magnitude? You know that these lines, parallel lines in which this V is included, of course we say it modulus of V or the length of V. So this is the notation for the magnitude of the vector. What is a unit vector? You know, a unit vector is the vector whose length is 1 unit. So dividing the vector by its magnitude, we can get the unit vector along the direction of vector V, and the notation is that we have a cap above the unit vector. Algebra of vectors, that how we can add, how we can subtract, how we can multiply a vector by vector, how we can multiply a vector by a scalar, and what will be the zero vectors. Addition of two vectors, as you know, there is law of triangle, law of parallelogram, law of polygonal. So we see on the screen. Here we have a vectors from O to the point A, and the vector from A to the point B, and a vector from O to the point B. Here we are adding the vectors A and B and getting the resultant vector, that is R. This is the law of triangle, that if you have these vectors A and B along adjacent side of a triangle in this direction, then the vector along the third side in the opposite directions will be the resultant vectors. So therefore the vector R is equal to vector A plus vector B. You can see here the polygon. Here the vectors OA, AB, BC, CD, DE and EF. These are the vectors A, B, C, D, E, F. These are in these directions, in same directions, along these sides, and the resultant vector will be along the opposite side, opposite directions, along the side O to F. So these are the laws how we add these vectors. Two vectors are equal if they have same magnitude and same direction. So you can see on the screen that we have here the vectors A and A which have same magnitude and same directions. But if a vector has the same magnitude and opposite direction, then its sign will be reversed. Zero vector, it is a vector which has no magnitude and take any direction. Parallel vectors. Two vectors are parallel if one can be written as a scalar multiple of other. Let us see. B vector is equal to lambda A vector, where lambda is a non-zero scalar. Here B is written as a scalar multiple of A. Now from here A can be written as 1 over lambda into B vector. So A and B vectors, these vectors are parallel vectors. Components of a vector. As we have seen, triangular law of addition of vector, the vector R is equal to sum of vectors A and B, and in polygonal law of addition of vectors, we have seen that R is equal to A plus B plus C plus D plus E plus F. These vectors are called component of the resultant vector R. A vector can be resolved into any number of components into given direction, but the most famous and most useful components are rectangular components, which are along the x-axis, y-axis, z-axis. Those are in the Cartesian coordinate axis system. If we have a point, say A, on the x-axis, whose coordinates are 1, 0, 0, and a point B on the y-axis having coordinate 0, 1, 0, and a point C on the z-axis having coordinate 0, 0, 1, then the length of these vector OA, OB, and OC are one unit, 1. So, and their direction is along the x-axis, y-axis, and z-axis respectively. So these are the units vectors along these axes. We denote them by I, J, and K respectively. If we have a point in space having coordinate x, y, z, then the vector OP can be written as xi plus yj plus zk. And if we denote this vector OP by R, then this resultant vector R is equal to xi plus yj plus zk. Why I said it resultant? Because this is the sum of these vector, that is xi plus y and yj and zk. This vector is also known as the position vector of the point P, and it has all the qualities to be a vector, because if you are given this vector R is equal to xi plus yj plus zk, we can find its magnitude and we can find its direction. How we find its magnitude? That is, you know that x square, magnitude of R is equal to x square plus y square plus z square under the square root, which is definitely the distance from the origin O to P. And how we can find the directions, we have already discussed in our previous lectures, that if this vector make an angle alpha with x-axis and beta with y-axis and gamma with z-axis, then cosine of alpha is x over magnitude of R, and cosine of beta y over magnitude of R, and cosine gamma will be that is z over magnitude of R. So this notation, this way of expressing a vector, has many advantages which we will see just now. That is how we can add the vectors in this form, in component form. So these rectangular component form will give us very easy way to add or to subtract or to multiply the vectors each others. So first of all, the addition and subtractions. Let us see. A is a vector which has component A1, A2, A3, that is A1 along the x-axis and A2 along the y-axis and A3 along the z-axis. So the vector A is equal to A1i plus a2j plus a3k, and the vector b is equal to b1i plus b2j plus b3k. So we add component wise. So it is very easy to add. So the addition, the sum of the vectors a and b, that's a plus b, is equal to a1 plus b1i plus a2 plus b2j plus a3 plus b3k. So just we are adding the components, x components in x components and y components into y components and z components into z components. And similarly for subtraction, a minus b, that will be a1 minus b1 I plus a2 minus b2 j and plus a3 minus b3 k. Multiplications. Now in vectors there are three types of multiplication. One, the very first one is multiplication of a vector by a scalar. If we multiply a vector by a scalar, then it has the same direction of the original vector, but the magnitude is scalar times of the magnitude of the original vectors. Let us see. We have a vector a, and you can see there is vector 2a, 3a. The vectors 2a has the same direction, that is that of a, but has the magnitude double that of a. And the vector 3a has the magnitude 3 times that of a. You can see here the vector minus 2a, which is obtained multiplying the vector a by minus 2. So it has the magnitude 2 times of a, but in the opposite direction. Using this thing, we can write any vector a by expressing it as scalar multiplication of the unit vector along the direction of a with the magnitude of the vector a. So the vector a can be written as equal to magnitude of a into the unit vector in the direction of a. There are now other multiplications. There are two types of multiplication remaining those. So the very first one here is the dot product, and the second one is cross product. The dot product is known as scalar multiplication, and the cross product is known as vector multiplication or vector product. Because the result of the dot product is the scalar quantity and the result of the cross product is the vector quantity. So first we take the dot product, that is the scalar product. The scalar product of the two vectors a and b is equal to the magnitude of a into magnitude of b into the cosine of angle in between them. Let us see on the screen. So a dot b is equal to magnitude of a into magnitude of b into cosine of theta, and here theta is the angle in between them. As you have seen, no direction is involved here. It has only magnitude, so it is a scalar product. This product is commutative. What I mean that a dot b is equal to b dot a. Let us see. So this is the result, that a dot b is equal to b dot a. Addition is also commutative. That is a plus b is equal to b plus a. This has some beautiful results we can see here. If a is perpendicular to b, then a dot b is equal to 0, because at that time our angle theta is pi by 2, 90 degree, and cosine then will be 0. So we have a beautiful result that if we want to test whether two vectors are perpendicular to each other or not, so we see whether their dot product, scalar product is 0 or not. Now, I dot j is equal to 0. Similarly, j dot I is equal to 0, j dot k is equal to 0, k dot j is equal to 0, k dot I is equal to 0, and I dot k is equal to 0. As you know that I, j, k are unit vector along x-axis, y-axis, z-axis respectively, and they are perpendicular to each other. If the vector A is parallel to the vector B, then A dot B is just the product of their magnitude. Why it is so? According to the definition, A dot B is equal to magnitude of A, magnitude of B into cosine of angle in between them. Because these are parallel, so angle is 0, and cosine 0 is equal to 1. So A dot B is equal to magnitude of A into magnitude of B, and from here we can also find a formula for magnitude, that the magnitude of A is equal to square root of A dot A. Now I dot I and j dot j and k dot A k is equal to 1, because these are parallel to each other, these are same, and their magnitudes is unit. For this we take example. So let us do one example for this. Here we have a vector A which is equal to 3k, and the vector B which is equal to square root 2 I plus square root 2k. Then A dot B is equal to magnitude of A, magnitude of B, cosine of theta, and that is equal to 3 into 2 cosine pi by 4 is equal to 6 square root 2 divided by 2 is equal to 3 under root 2. How we can represent our this dot product, scalar product result into components form when we are given rectangular components form of the vectors? And let us see on the screen. The vector A is equal to A1i plus A2j plus A3k, and vector B is equal to B1i plus B2j plus B3k. So A dot B, if we calculate these and using all those results which we have just stated, that is, those are I dot j will be k, I dot k will be j, and I dot I is equal to 1, just like those. So we will reach on the result that A dot B is equal to A1 B1 plus A2 B2 plus A3 B3. You can see that this scalar product in this form is very easy. Just you multiply the respective components and add them. Angle between the two vectors. Now from here, from this definition, we can easily find that what is the angle between them. Let us see. From the definition that A dot B is equal to magnitude of A, magnitude of B into cosine of theta. So cosine of theta will be equal to A dot B divided by magnitude of A multiplied by magnitude of B. And from here we can find theta. And theta lies between 0 to pi. Let us do one example finding the angle between two vectors when the two vectors are given in components form. Let us do. We have a vector I minus 2j minus 2k, and the vector B is equal to 6i plus 3j plus 2k. Please note these vectors maybe in 2 dimension or 3 dimension. So we can take the example of 2 dimension and we can take the example of 3 dimensions. So here A dot B is equal to 1 into 6 plus minus 2 into 3 plus minus 2 into 2, and which is equal to 6 minus 4 is equal to minus 4. Also we are going to find the magnitude of A. Magnitude of A, as I have told you, that is equal to, for a vector whose position vector is xi plus yj plus zk, is given by x square plus y square plus z square square root. So here the magnitude of A is 1 square plus minus 2 square plus minus 2 square and the square root of it, and which is equal to square root of 9 is equal to 3. And magnitude of B is equal to 6 square plus 3 square plus 2 square, and which is equal to square root of 49, and that is 7. So theta will be cos inverse of A dot B divided by magnitude of A and magnitude of B. So that is equal to cos inverse of minus 4 by 21, and which is approximately equal to 1.76 radians. Projection of a vector in a given direction. So let us, we have a vector B and we want to find the projection of vector B in the direction of a given vector A. Let us see. Here we have a vector A along the direction OA and the vector B along the direction OB. The angle in between them is theta. Drop a perpendicular from B onto OA, meeting OA at the point C. OC length is the projection of the vector OB in the direction of A. So this is the scalar quantity, scalar projection. You can see here that OC divided by OB is equal to cos theta. So OC is equal to OB cos theta. So the projection of the vector B in the direction of A is equal to magnitude of B into cosine theta. If we multiply and divide by the magnitude of A, we get magnitude of B into magnitude of A into cosine theta divided by magnitude of A. Numerator becomes B dot A, as we have defined the scalar product. So we have B dot A whole divided by magnitude of A, and we can write it B dot A divided by magnitude of A. A divided by magnitude of A is the unit vector in the direction of the vector A. So what we have got the formula is that whenever we want to find the projection of vector B in the direction of a vector A, then find the dot product of B with the unit vector along the direction of A. So this is the scalar projection. We can also talk about the vector projection. Vector projection will be a vector and the direction will be along the vector A. So this B dot unit vector of A is equal to B dot A divided by magnitude of A, and we give it to the direction, multiplying it by the unit vector along the vector A. It will be a multiplication of the vector by a scalar, because B dot into unit vector along A is a scalar quantity, and we attach the direction by taking it just as a coefficient of the unit vector along the vector A. So B dot unit vector A is a scalar quantity, and we have multiplied it by the unit vector along the vector A, and we are getting it in this way: B dot A divided by A dot A, and multiply this scalar by the vector A. So when we want to find the scalar projection of the vector B in the direction of vector A, find the dot product of vector B and the unit vector of the vector in the direction of vector A. And if we want to find the vector projection of the vector B in the direction of vector A, so first of all find B dot A and A dot A, these are two scalar quantities. Divide B dot A by A dot A, so you get a scalar quantity, and attach the direction with it, that is multiplying this scalar with the vector A. इन दोनों बातों के लिए हम एग्जाम्पल करते हैं. The scalar component of the vector B in the direction of A, if we have B is equal to 6i plus 3j plus 2k, and A is equal to I minus 2j minus 2k, the unit vector along the direction of A will be obtained by dividing the vector A by its magnitude. The magnitude of vector A will be equal to 1 square plus 2 square plus 2 square and square root, which is equal to 3. So the unit vector along the direction of A is equal to 1 by 3i minus 2 by 3j minus 2 by 3k. So just we have discussed that the scalar component will be equal to B dot this unit vector, and which will give us 6 into 1 by 3 plus 3 into minus 2 by 3 plus 2 into minus 2 by 3, and which is equal to 2 minus 2 minus 4 by 3, and which is equal to minus 4 by 3. We come to the next example for finding a vector projection of the vector B in the direction of A. Here B is 6i plus 3j plus 2k, and the vector A is I minus 2j minus 2k. I have stated the rule or the formula for this, that find B dot A and A dot A. So the finding B dot A will be 6 into 1 plus 3 into minus 2 plus 2 into minus 2, which is equal to 6 minus 4, which is equal to minus 4. And A dot A is equal to 1 square plus minus 2 square plus minus 2 square, which is equal to 1 plus 4, and which is equal to 9. So the scalar quantity B dot A divided by A dot A will be equal to minus 4 by 9. And for attaching the direction, we will multiply the vector A by this scalar minus 4 over 9, giving us minus 4 over 9 into I minus 2j minus 2k, which is equal to minus 4 by 9i plus 8 over 9j plus 8 over 9k. अब तक हमने दो किस्म की मल्टीप्लिकेशन की, एक वेक्टर की स्केलर के साथ जिसका कि रिजल्ट वेक्टर था, और एक दो वेक्टर्स की, एक वेक्टर्स की दूसरे वेक्टर्स के साथ, लेकिन उसका रिजल्ट स्केलर था. एक तीसरी मल्टीप्लिकेशन भी होती है वेक्टर्स में, जो कि वेक्टर प्रोडक्ट या क्रॉस प्रोडक्ट कहलाती है, और उसका रिजल्ट वेक्टर होता है. अगर हमारे पास दो वेक्टर ए एंड बी हैं, तो इनका क्रॉस प्रोडक्ट हम इस तरीके से डिफाइन करते हैं. ए क्रॉस बी इज इक्वल टू मैग्नीट्यूड ऑफ ए इंटू मैग्नीट्यूड ऑफ बी इंटू साइन थीटा, where theta is angle in between them. And the direction of this vector will be perpendicular to the plane containing the vector A and B. If we denote the unit vector along this direction by n, then A cross B is equal to magnitude of A into magnitude of B sine of theta and the vector n. Let us see on the screen. So here we can see that A cross B is equal to, just I have stated, that magnitude of A, magnitude of B, sine theta n, where n is a vector determined, a unit vector determined by right hand rule. What is the right hand rule? You can see on the screen that if we multiply A by B, so if we go from A to B anti-clockwise directions, then our direction will be perpendicular to the plane containing the vector A and B in the direction where our thumb pointed out. But if we multiply the vector B by A cross product, B cross A, B first then A, so we will be in the direction of clockwise, and that in that way the direction will be opposite and will be of this type. So in this way we find the cross product of these vectors. We have few results about these cross product. These are very basic result which will be used in our further calculation. Let us see these result. If A is parallel to the vector B, then A cross B is equal to 0. Why it is 0? Because at that time the theta is equal to 0 and sine 0 is equal to 0. So A cross A is 0. So a cross product of a vector by itself is always 0. So this will give us I cross I, J cross J, K cross K is equal to 0. If A is perpendicular to B, then A cross B is equal to magnitude of A into magnitude of B into the direction. So that is, if we take the magnitude of A cross B and B are perpendicular to each other, then it is just the multiplication of their magnitude. here theta is equal to 90 degree and sin theta is equal to 1. And this vector, and if it is a vector, then definitely it is perpendicular to the plane containing A and B. Now our special unit vectors I cross j is equal to k, because k will be perpendicular to the plane containing I and j. That is, the z-axis is perpendicular to the plane containing x-axis and y-axis. And since their magnitudes are 1, so therefore the result is only k. And j cross k is equal to I. Similarly, k cross I is equal to j. But if we change the direction, so j cross I is equal to minus k, and k cross j is equal to minus I, and I cross k is equal to minus j. You can easily note that this cross product is not commutative. So A cross B is not equal to B cross A, but it will be in, you can say, of the opposite directions. For remembering the sign, we can use this figure, this diagram. So if we go from I to j, the result will be k, and if we go from j to k, the result will be next I, and if we go from k to I, then the result will be j. अब जिस तरीके से हमने स्केलर प्रोडक्ट को रेक्टेंगुलर कंपोनेंट फॉर्म में भी किया, इसी तरीके से क्रॉस प्रोडक्ट को भी हम रेक्टेंगुलर कंपोनेंट फॉर्म में देखेंगे कि अगर हमारे ये वेक्टर जो हैं रेक्टेंगुलर कंपोनेंट फॉर्म में दिए गए हों तो हमारी क्रॉस प्रोडक्ट कैसे होगी. आइए देखते हैं. A is a vector equal to a1i plus a2j plus a3k, and B is vector which is equal to b1i plus b2j plus b3k. So A cross B, you will find this product, and this is a heavy calculation using those laws which we have just defined, that where there is I cross I, it will be equal to 1, j cross j is equal to 1, k cross k is equal to 1, I cross j will be equal to k, or j cross I is equal to minus k. So just we have discussed. So using these, ultimately you will reach on the result that A cross B is equal to A2B3 minus A3B2 I minus A1B3 minus A3B1J plus A1B2 minus A2B1K. And if you find the value of this determinant, whose first row is I, j, k, and the second row is A1, A2, A3, and the third row is B1, B2, B3. If you evaluate this determinant, you will reach on the same result, which is A cross B. So the easy and handy method for finding the cross product is using this determinant. So हमने A क्रॉस B को डिफाइन किया और उसको एवेल्युएट करने का डिटर्मिनेंट का मेथड दिया. आइए इसकी एक एग्जाम्पल करते हैं. एग्जाम्पल, गिवन A is equal to 2i plus j plus k, B is equal to minus 4i plus 3j plus k, then A cross B is equal to the determinant first row ijk, second row 2 1 1, and third row -4 3 and 1. Solve this determinant please, and you will get A cross B is equal to -2i minus 6j plus 10k. Now if we find B cross A, so definitely it will be equal to minus A cross B, so multiplied by minus, which is equal to 2i plus 6j minus 10k. And you remember, if you use the determinant method for B cross A, what will happen? The row 2 and 3 will be interchanged, and you know that by interchanging the two rows, the sign of the determinant is changed. Please ये इसका क्रॉस प्रोडक्ट का एक ज्योमेट्रिकल एस्पेक्ट भी है, और वो ये है कि अगर हमारे पास एक पैरेललोग्राम है जिसकी के दो एडजेसेंट साइड हम वेक्टर्स ए और वेक्टर बी से डिनोट करें, तो ए क्रॉस बी वेक्टर का जो मैग्नीट्यूड है वो हमें इस पैरेललोग्राम का एरिया मुहैया करता है. देखते हैं कैसे. ये हमारे पास डायग्राम में ये पैरेललोग्राम आपको नजर आ रही है, और इस पैरेललोग्राम में हमारे पास जो इसके किस हाइट जो है दैट इज h, और वो हाइट हम कैसे निकाल सकते हैं, विच इज इक्वल टू मैग्नीट्यूड ऑफ b इंटू साइन थीटा, बिकॉज यू नो h over magnitude of b is equal to sin theta. So h is equal to magnitude of b into sin theta. Area of the parallelogram is equal to base into height. Base is the magnitude of a and height is magnitude b into sin theta. So this area will be equal to magnitude of a into magnitude of b into sin theta, and we know this is the magnitude of the cross product of the vector a and b. So in this way we can find the area of parallelogram. आज के लेक्चर में हमने वेक्टर्स की इब्तदाई बातें की. आइंदा लेक्चर में हम वेक्टर्स की मज़ीद कुछ और बातें करेंगे, और इसके बाद हम इसको अप्लाई करेंगे कैलकुलस में, और उसी लेक्चर में डायरेक्शनल डेरिवेटिव्स का टॉपिक पढ़ेंगे. उस वक़्त तक के लिए खुदा हाफिज़.